Hello and welcome to my channel. I am the Mad Computer Scientist. If you are new to this channel, please take a minute to like, comment, and subscribe. On this channel, I discuss math, computer science, and technology topics that are of interest to me. And one of those topics is something put forth by a viewer today who suggested I try to cover the trial division algorithm. The trial division algorithm is essentially a way of getting the prime factorization of a number. If you recall from your algebra classes, you may know that the fundamental theorem of arithmetic states that for every integer greater than 1, there is a unique prime factorization. And the trial division algorithm is just a way of figuring out what that unique prime factorization is. Now, this took me quite a while to implement in a way that works. I finally got it working in Python late last night. What you're seeing on the screen is a result of the code I was working on. So we're going to start by going with what's highlighted down there, and that's basically just a way to tell Python that if we're running from the command line, we want to call the main function. This is something I personally like to do because in other programming languages, you'll either have a main block that controls the function flow, or for languages like C and Java, you have a main function that controls the flow of your program. In this case, we're going to do some really basic stuff in our main function, like inform the user what we're doing. That's what the first print statement is for. We're going to check for valid input. We do that by setting a flag variable, in this case valid input, equal to false. And while not valid input, as long as valid input equals false, what we're going to do is ask the user for a number, and we're going to typecast whatever the user types in from the input command. Then we're going to check to see if the number is greater than 1. If it is, we set the value of valid input to true, and the loop ends. Now, we want to know, without doing trial division on it, if the number is already prime. Technically, this step is probably unnecessary, but it's going to save us some time. So, we're going to call isPrime. If the number passed to the function is less than 1, we just return false because it's not prime. But if the number is 2 or greater, we're going to multiply I times I. And as long as that result is less than or equal to the number, we're going to go through the value of I. For each value, we're going to take number mod I and see if that result is 0. Basically, modulus division is a way Python lets us determine what the remainder of integer division is. So obviously, if we do that, if we get a remainder of 0, the number isn't prime, it's composite. So what we're going to do with that is use the value of easy factor, and if easy factor return true, we're going to just say that the factors are 1 in the number. Otherwise, we're going to do trial division. So trial divisions is going to work similarly to the way the isPrime function worked, except we're going to do some interdivision, which will actually, hopefully, reduce the runtime for numbers that are not prime. So we start by setting another variable I, which equals 2, and if you paid attention, you might be wondering, hey, isn't that the same variable we used in isPrime? And the answer, believe it or not, is no. This has something to do with something called scope, which is unique to each language, but in Python scope, each function is its own scope. So the I that we declared in isPrime is not the same I we have declared in trial division. We are also going to declare an empty list called prime factors, which we will simply use to store any number that is a factor of the number we're trying to determine its prime factorization of. So we're going to start with 2, and while I times I is less than or equal to f number, we're going to do the same thing we did with isPrime. But in this case, if it is 0, we're going to append I to prime factors, and then we're going to do interdivision and divide f number by I. If that doesn't happen, we just increment I. And once we hit I times I being greater than f number, we don't need to continue because we either have gotten all the factors or the number again is prime. So once that ends, we should have one integer left over. So what we're going to do if that integer isn't equal to 1, we're just going to append that number to prime factors and print it out to the screen. And that is how trial division works in Python. You do not have to do it in Python if you do not wish. You can implement it in any other programming language you know. In fact, if you were to implement it in a language like C, it would probably be faster. If you are a masochist, you can even do it in Rust. You can do it in Perl, and you can do it in COBOL. You're probably wondering, if you're an advanced computer science student, what the runtime complexity of this algorithm is. And looking at the trial division algorithm, should be the square root of n. And that's a worst case scenario, keep in mind. Typically, it's probably going to be a little bit better runtime complexity than the square root of n, but that is not always going to be the case. And that is trial division, everyone. Now go out and write some code.